Okay, we're back with the 45, 45, 90. I had to double check something. I was missing something in this picture here, that the hypotenuse should be a times the square root of 2. Okay, so we have our 45-degree angles here. So we want to use our 45, 45, 90 formula to help us figure out what the lengths of these sides should be. That will give us the point where this angle intersects the unit circle. Now again, what we know is that the length from the center of the circle extending to the edge is equal to the radius, which the radius for the unit circle is 1, hence why they call it a unit circle. So we know that the hypotenuse is 1 again. Now we need to solve for a in this formula, so that way we can figure out the lengths of these other two sides. So we know that a times the square root of 2 is equal to 1. So a times the square root of 2 is equal to 1. Now we need to solve for a, right? So we need to divide by the square root of 2. Someday I'll be able to actually write with this thing legibly. So a is equal to 1 over root 2. Now we're going to do something called rationalizing this fraction. We don't typically write square roots in denominators. So the way we rationalize this fraction is we multiply top and bottom by the square root of 2. So what we end up getting here is the square root of 2 over, and then the square root of 2 times the square root of 2 is 2. So our a value is root 2 over 2. So that's going to be the lengths of both legs of this triangle. So this is going to be root 2 over 2. This is also going to be root 2 over 2. So what does this mean? What are the coordinates for this point here? Well, they're equal to the legs of this triangle, which is going to be root 2 over 2, root 2 over 2. So those are the coordinates for our 45-degree angle, right? So in radians, remember this is pi over 4, or 45 degrees. And our coordinates are root 2 over 2, root 2 over 2. All right, we're almost done here. Now we're going to go to the 60-degree angle. And this is going to be very similar to how we did the 30-degree because we're going to use the 30, 60, 90 again. So again, I'm going to draw the triangle. So let me go back here. Now what we're focusing on is we're focusing on the 60-degree angle. So it's going to be this angle right here. So this is 60 degrees. Remember, this is pi over 3 in radians. So we're trying to figure out what the coordinates for this point are, right? We're trying to figure out what the coordinates for that point. So we're going to use the formula for 30, 60, 90 again. So I'm going to draw the triangle out here. Okay. So this is our 60-degree. Obviously that other angle is our 30-degree, and then we have our right angle. Now again, the hypotenuse is 1 because it is the unit circle. The length from the center all the way to the edge is given by 1. And now we're going to use the same thing we did before, right? How did we solve for the a value before? Well, we set 2a equal to 1. So that means that a is equal to 1/2. So what does that tell us? That tells us that the side adjacent to 60 degrees is a, which is 1/2. We solved for that before, right? So the side adjacent to 60 degrees this time is down here on the bottom, 1/2. And then the side across from 60 degrees is going to be the square root of 3 times a, which we saw before was the square root of 3 times 1/2, which is the square root of 3 over 2. So this is the square root of 3 over 2. That was easy. So this time, for our 60-degree angle, it's basically just the numbers for the 30-degree just flipped. Our x value is 1/2. Our y value is the square root of 3 over 2. And that's how we get the 3 standard angles in our unit circle, right? Pi over 6, pi over 4, and now pi over 3. So that's how we get our 30 degree, 45 degree, and 60 degree. Now, before I end this video, what I want to do is figure out what should be the appropriate values for 0 and 90 degrees. So this is going to be our 0 degree angle, which I mean you could also just think of as 0 in radians. Now, we're just trying to figure out what is the coordinates of this point right here. So this angle just lies on the x-axis, right? So it's just a straight line. Well, what is the length of the center of the circle extending to the edge of the circle? It's equal to the radius, right? The radius is the length from the center to the edge. Well, since this is a unit circle, this length is 1. Now, should 1 be our x value or our y value? Well, obviously our x value, so our x coordinate's 1, y coordinate's 0, it doesn't go up or down. And so this means the cosine of 0 is 1, sine of 0 is 0. Now let's go to 90 degrees. Now I'm doing these sort of separately because they're more straightforward. There's not really any calculations you have to do. So our 90 degree angle, right? We're trying to figure out what are the coordinates of this point right here. Now again, what happens with the 90 degree angle? We'll delete this so that way it's not that much confusion. Well, the angle, straight up, intersects the unit circle right here, right? Now, again, we have this line, this angle going from the center all the way to the edge, so that means this length should be 1. Now, at this point right here, should our x value be 1 or our y value be 1? Well, clearly our y value should be 1, and our x value is 0. So this means for 90 degrees, or pi over 2, this means that our cosine is 0, our sine is 1. So cosine of 90 degrees, or cosine of pi over 2 is 0, sine of pi over 2 is 1, or sine of 90 degrees is 1. So far what we've done is we've derived the first quadrant of the unit circle. In the next video, what we're going to do is figure out how to derive the remaining angles inside of our unit circle. I'll do a couple of examples, have you try some, and then by the end, you should have all the tools you need to fill in the remainder of this unit circle. And I'll tell you exactly how you need to fill in these pieces.